Hi, this is Stephen Cherry for Radio Spectrum. Let's face it, the United States and really the entire world has squandered much of the time that has elapsed since climate change first became a concern more than 40 years ago. Increasingly, scientists are warning that taking coal plants offline, building wind and solar farms here and there, and planting trees even everywhere aren't going to keep our planet from heating to the point of human misery. 20 years from now, we're going to wish we had started thinking about not just carbon zero technologies, but carbon negative ones. Last year, we spoke with the founder of Air Company, which makes carbon negative vodka by starting with liquid CO2 and turning it into ethanol, and then further refining it into a product sold in high-end liquor stores. Was it possible to skip the final refining steps and just use the ethanol as fuel? Yes, we were told, but that would be a waste of what was already close to being a premium product. Which leads to the question, are there any efforts underway to take carbon out of the atmosphere on an industrial scale? And if so, what would the entire product chain look like? One company already doing that is Global Thermostat, and its CEO is our guest today. Graciela Chichilniski is, in addition to the startup, an Argentine-born professor of economics and mathematical statistics at Columbia University and director of the school's Consortium for Risk Management. She's also co-author of a July 2020 book, Reversing Climate Change. Graciela, welcome to the podcast.
Thank you, Stephen. Pleasure to be here.
Graciela, you have two pilot facilities in California. They will each have the capacity to remove 3,000 to 4,000 metric tons of CO2 per year. How exactly do they operate?
The actual capacity varies depending on the equipment, but you are right on the whole. And the facilities are SRI, which used to be the Stanford Research Institute. They work by removing CO2 directly from air. That technology is called direct air capture. And our firm, Global Thermostat, is the only American firm doing that, and it is the world leader. The technology essentially scrubs air. So you move a lot of air over capture equipment and chemicals that have a natural affinity for CO2. So as the air moves by, the CO2 is absorbed by the solvent. And then you separate the combination of the solvent with the CO2, and lo and behold, you get yourself 98% pure CO2 coming out as a gas at 1 atmosphere. That is very, very, very high level how it works, but the details are, of course, much more complex and very, very interesting. What is most interesting, perhaps, is that chemists who are used to working with constrained capture in limited facilities or volumes find that much of the chemical and physical properties of the process change when you are acting in a non-constrained area, in fact, the whole atmosphere. You are using the air directly from the atmosphere to remove the CO2. That's why it is possible to do that in a way that we have patented. We have about 70 patents right now, in a way that is economically feasible. It's possible to do it, sell the CO2, thus obtain and make money. And that is, in fact, the business plan for our company, which includes reversing climate change through this process.
Yeah, so let's take the next step of the process. What happens with the CO2 once it's at its 98% purity?
The CO2, what is perhaps a well-kept secret for most people, is that CO2 is a very valuable gas. And even though it's a nuisance and it's dangerous, depending on the concentration in the atmosphere, here on Earth, it sells for anywhere between $100 a ton and $1,500 or $1,800 a ton. If you think about that, all you need to know is that the cost of obtaining the CO2 from air should be lower than the cost for selling it. The question is what markets would satisfy that. And I'm going to give you markets in which we are already working and some in which we are not working yet. We're already working with the production of synthetic fuels, in particular, synthetic gasoline. Gasoline can be produced by combining CO2 and hydrogen, the CO2 from air, the hydrogen from water. The hydrogen is produced using hydrolysis, and the CO2 comes from air using our technology. Combining those two gives you a hydrocarbon, and when properly mixed, you obtain a chemical which is molecule by molecule identical to gasoline, except it comes from water and air instead of coming from petroleum. So if you burn it, you still produce CO2, but the CO2 that is emitted came from the atmosphere in the production of the gasoline. And therefore, you have a closed circle. And you're not, in net terms, you're emitting nothing using the gasoline that is produced from CO2 and hydrogen, from air and water. The markets currently used in our case, in addition to synthetic gasoline, include the water desalination market. We work with a company that is the largest desalinator of water in the world, in Saudi Arabia. They need a lot of CO2 because the process of desalinating water for human consumption requires the use of CO2. In addition, there are carbonated beverages. For example, beer and Coca-Cola. Indeed, we work with Coca-Cola, and we work with Siemens and with AME and automobile companies such as Porsche to produce the clean gasoline, the synthetic gasoline I mentioned, from the CO2 from air. You can actually produce elements of cement and other building materials. So as a whole, McKinsey has documented that there is a $1 trillion market per year for CO2. So CO2 is a very valuable chemical on Earth, even though it's a nuisance and it's even dangerous on the atmosphere. So the notion of global thermostat is bring it down, take it from the atmosphere where it is dangerous, bring it down to Earth where it is valuable.
I love that our first carbon negative podcast involved vodka and our second one now involves beer. There's a certain amount of energy used in the processes of removing CO2 from the air and then using it. For some of these applications, what would be a typical net carbon budget?
Negative. In other words, what happens is we don't use electricity, which is, as you know, mostly produced from fossil fuels. We use heat, and our heat can be produced as a waste heat from other processes. Doesn't have to be electricity. In fact, we use very little electricity. But think of it this way. In the year 2020, for the first time in history, humans are able to produce electricity directly from the sun less expensively than using fossil fuels. The 2.5 cents or less per kilowatt hour is the going price for solar photovoltaic production of electricity. It's the lowest cost. 2 cents a kilowatt hour is really the lowest possible cost.
One wonderful thing about this is that you're an economist, and so you're determined not just to develop technologies, but ensure that they find a home in the marketplace, because that's the most practical way to implement them at scale. In 2019, Global Thermostat started working with ExxonMobil. I understand they provided some money and I believe initially 10 employees. I gather the idea is for them to be one organization commercializing this technology further. How would that work?
Well, first of all, I do have two PhDs. I studied pure mathematics at MIT. That was my first PhD. My second PhD was in economics at UC Berkeley. So I do have the mathematics as well as the economics in my background. What we're doing requires several forms of expertise. You said it, Global Thermostat has made a joint development agreement with Exxon and is working with Coca-Cola and is working now with Siemens. Is working with a company called HIF, which is in Chile. So how does that work? As you probably know, ExxonMobil is a multifaceted company. In addition to fossil fuels, they have a huge expertise in carbon capture technology of the old-fashioned, I would say, traditional type. And by that means capture of CO2 from the fumes of power plants, for example. They have the resources and the know-how, and we are a small company, and we want to expand our production. So they offer an opportunity for us to talk with a highly technologically advanced company in the area of carbon capture in a more traditional way that are willing to experiment and they're willing to advance commercially the removal of CO2 directly from the atmosphere. So that is what with them in our contract, we intend to build a 1 gigaton plant. That's what we contracted to do, which means that with them, we will scale up our technology. So every year, it can eventually remove 1 billion, with B as in boy, tons of CO2 from the atmosphere every year. That's the scale up I'm talking about. And that is the main purpose of our partnership with ExxonMobil. And if you think about it, you said it yourself, you want to know about the carbon budget. Very roughly speaking, don't forget that I worked in the Kyoto Protocol and I created the carbon market of the Kyoto Protocol. So I know a lot about carbon budgets and how demanding they are and how far we are from what we need to do. We need to essentially remove 40 gigaton of CO2 every year from the atmosphere in order to reverse climate change. And what I'm telling you is that with this type of partnerships with companies like Exxon, we can do 1 gigaton. You are at a shooting distance from that goal. And that's why our contract with Exxon is to scale up our technology to remove 1 gigaton of CO2 per year. And then if we had 40 of those plants, then we would be removing all the CO2 that humans need to remove from the atmosphere right now in order to reverse climate change.
It seems paradoxical that it would make more sense to take carbon directly out of the air, the direct air capture, rather than focusing on concentrated sources of carbon and carbon dioxide, such as a power plant smokestack. How is that paradox resolved? How is it more sensible to take it directly out of the atmosphere?
First of all, it's not sensible. It's very creative, very unique, and it has never been done. Not what we're doing has never been done. And there is a good reason why it was never done. Because as you point out, it's more difficult, actually, and it's more expensive to remove CO2 from the air than to remove it from a concentrated source. So why would we be doing that? The answer is, if you remove CO2 from the chimneys of an industrial facility, the best you can do, the best possible, is to make that facility carbon neutral, to remove all the CO2 that it is emitting. That's the best, if you're really lucky, right? Okay, that's not enough anymore. When I used to be the lead author of the IPCC, the Intergovernmental Panel of Climate Change, working on this topic, I found, and it is well known now, that going carbon neutral does not suffice. I think you say that in your introduction. Now we have to go carbon negative, which means we have to remove in net terms more CO2 than what is emitted. And that CO2 that we remove should be stabilized on Earth. I'm not saying sequestered underground, but I'm saying stabilized. It could be in materials or in cement or concrete, whatever, but stabilized on Earth after it's removed. If you need to remove more CO2 than what you emit, and we need to remove 40 gigaton more than what we emit right now, you cannot do it from industrial facilities. The best that you can achieve is carbon neutrality. You need to go carbon negative. For that, you have to go and remove CO2 from air.
I said that 20 years from now, we'll wish we had started all this 20 years earlier, but you actually started this process a decade ago. You already foresaw that we would need carbon negative processes. But at the same time, as you mentioned, you were also working to develop the Kyoto protocols, specifically creating carbon markets. Was that just a stopgap before getting to this point that you're at now?
No. The carbon market is the solution, was the solution, and is the solution. Let me explain. The problem is that our prices are all wrong. And when we try to maximize economic performance, we maximize a GDP in which we don't take into account the enormous damage that excessive CO2 emissions are causing to humans, to our economy, to our world, and even to our survival as a species. The introduction of the carbon market, I invented it, and I designed it, and I wrote it into the Kyoto Protocol in 1997, was done with the purpose of changing the system of values. In other words, introducing prices and values that make it more desirable to be clean rather than to over-emit. Right now, if we were to cut all the trees in the United States and produce toilet paper, our economic system of economic performance, how we measure it, will say that we are much better off after all the trees have been cut off and used to produce toilet paper than before. So I decided that this had to change. And in fact, when I designed and created the carbon market of the Kyoto Protocol, it became international law in 2005. And it is now what's called the European Union Emission Trading System, which encompasses 27 nations. It's also used in China, in 14 states in the United States, and essentially 25% of humankind is using now the carbon market that I designed and wrote into the protocol originally in the year 1997. But the most important statistic for me is in December 2019, Physics Today, there is an article on the carbon market where it says that the carbon market has succeeded by decreasing the emission from the nations that use the carbon market in those years, since 2005, when it became international law, decreasing the emission in those nations that use the carbon market by 30% from the base year. Another way of saying it is that the whole world was using not just the 25% that I mentioned, the carbon markets. We will be 30% below the level of emissions of 2005. And you know what? We really wouldn't have the climate disaster, the catastrophe that we fear. We will not have it because we would be containing the emissions of CO2 through the use of the carbon market, as was done in all the nations that adopted the carbon market when it became international law in 2005. So that's a solution. But we haven't adopted it. Only 25% of the world succeeded. The rest of the world went south. We emitted even more. So now, in addition to decreasing emissions, because you cannot avoid decreasing emissions, that's critical, you now have to remove the CO2, the legacy CO2 that we put into the atmosphere and which is still in the atmosphere after all these years. So from the physical point of view, you have to know CO2 doesn't decay as fast as other gases, and it remains in the atmosphere once emitted for decades, even hundreds of years in some cases. As a result of that, we do have a lot of legacy CO2 that doesn't decay.
The title of your book is Reversing Climate Change. The subtitle is How Carbon Removals Can Resolve Climate Change and Fix the Economy. Perhaps you want to say another word about the fix the economy part?
Yeah, I will do it with two sentences. A sentence one, I just want to quote new President Biden, who said, when I think about climate change, he said, I think jobs, jobs, jobs. So a technological evolution of this nature, that could be even a revolution, is creating a lot of jobs. And it is creating the infrastructure that will allow us to solve the problem and grow the economy at the same time. Because every time you remove CO2, you make money now. It doesn't cost money. You have to invest initially, but you make money. That's the first part. The second issue, he doesn't address because he doesn't know this level of detail or this type of focus, is that the problem of the environment and the resources is very closely tied with the problem of inequity. And you must be aware, because there have been a number of books that were very prominently published and reviewed about the increase in the inequity in the global economy, not just international, that we know is huge. It has increased 20 times since 1945, but also within nations, like in the United States. Well, what's interesting is that these new technologies not only solve the problem at the technological level, and not only can bring jobs, as I mentioned, and I quoted Biden saying so, but in addition, these technologies sponsor equity. And I will give you two examples very quickly. As I mentioned already, the solar photovoltaic revolution, in which 80% of the cost of the production of electricity from photovoltaic energy has decreased in the last 12 years. That revolution has created a more accessible form of energy than ever before. Because while fossil fuels, that were the main raw material for the production of electricity in the $60 trillion power plant economy, those are really not very equitable at all. And fossil fuels come from a few regions in the world. They have to be also extracted from under the earth, etc. And the result of that is that our whole energy production system lies at the foundation of the inequity of the modern economy, the Industrial Revolution. If you replace fossil fuels, natural gas, petroleum, and coal by the sun as an input, you have a major equalizer because everybody in the world has access to the sun in the same amount. So the input now is no longer fossil fuels that come from a few places that make a lot of money, but the input now is the sun that comes from everywhere and everybody has access to. That's the input that creates energy now. That's more equitable. It's a huge difference. Huge difference. And the other difference is that with the new technology that transforms CO2 into material for construction, even into clean forms of energy, like synthetic gasoline, as I explained before, that is based on air as an input. And the air has a property, it has the same concentration of CO2 all over the planet. And this means an equalizer again. So we now can produce cement, let's say, beverages, food. You can even produce protein from CO2, of course, because it's the carbon molecule. You can actually produce all the materials that we need, and even food, beverages, from air. And the air is equitably distributed. It's one of the last few public goods that everybody has access to, as is the sun. So we are now going into a new economy, powered by sun and with resources coming from air. You know what? that solves the problem of equity in a big way. I would say inequity, which is so paralyzing to economies and to the world as a whole. So I wanted to say, not only this is an environmental change, some may say a revolution, but it's in addition a social and economic change, and some would say a revolution.
We could do an entire show on things like the resource paradox. Countries that are rich in oil, for example, end up being poorer through the extraction processes than when they started. Well, Graciela, it's going to take economists, business people, scientists, and politicians to lead us out of this crisis. And we're fortunate to have in you someone who is several of those things. Thank you for your research, your book, your company, your teaching, and for joining us today.
Great. Thank you very, very much for your time and for your insightful questions.
You're quite welcome. We've been speaking with Graciela Ciesielnicki, Columbia University economist, co-author of the 2020 book Reversing Climate Change, and CEO of Global Thermostat, a startup devoted to pulling carbon out of the air cost-effectively. Radio Spectrum is brought to you by IEEE Spectrum, the member magazine of the Institute of Electrical and Electronic Engineers, a professional organization dedicated to advancing technology for the benefit of humanity. This interview was recorded February 2nd, 2021 via Zoom and Adobe Audition. Our theme music is by Chad Crouch. You can subscribe to Radio Spectrum on Spotify, Apple Podcast, and wherever else you get your podcasts, or listen on the Spectrum website, where you can also sign up for alerts of new episodes. We welcome your feedback on the web or in social media. For Radio Spectrum, I'm Stephen Cherry.